All right, let's go through the practice problems. The first one, we have 8 to the quantity x plus 3 equals 32. There's a couple ways that we could go about solving this. First of all, you might recognize that 8 and 32 are both powers of 2. If you don't recognize that, you don't need to. You can solve it a different way as well. So let's solve it as if we didn't recognize that we could rewrite those with a base of 2. And because it's x plus 3 here, we are assuming that the bases were being multiplied originally, so we could rewrite that using the exponent properties of 8 to the x times 8 to the third. And that would be equal to 32. And then when we take 8 to the third power, we get 512. So we have 8 to the x equals, 8 to the x times 512 equals 32. In order to get 8 to the x by itself, we're going to divide by 512. And so we get 8 to the x equals, and when you reduce that fraction, you get 1 over 16th. Now, there's two ways you could solve it from here. One way is to use log properties, because we have 8 to the x power equals 1/16, so you could use the power property of logs to solve it. But since we're in an exponent unit, let's solve it keeping in line with our exponents and our rewriting idea. So I'm just going to go up to here, and I'm going to rewrite 8 as 2 to the third power, because 2 times 2 times 2 is 8, right? So 2 to the third power to the x equals, I'm going to rewrite 1/16 as 1 over 2 to the fourth power, because 2 times 2 times 2 times 2, 4 times, however many times I said it, is 16. And then we can rewrite it without a fraction as 2 to the negative 4. And we can rewrite this side as 2 to the 3x. And now that we see that we have the same bases on both sides, we can just write the equation as 3x equals negative 4. Divide by 3, we get x equals negative 4 thirds. So lots of ways to solve this problem. If you did it a different way, totally fine. Let's go on to the next problem. We have 27 to the 2x equals 1/9 to the x minus 1. This is another problem where we want to find common bases if we can. So 27 and 9 can both have a base of 3. So I'm going to rewrite it as 27 as 3 cubed to the 2x. And rewrite 1/9 as 1 over 3 squared, all raised to the x minus 1. So I can simplify this side, because if I'm raising an exponent to a power, I can multiply those. So I have 3 to the 6x. I can simplify the other side by getting rid of the fraction and writing it as 3 to the negative 2 raised to the x minus 1 power. Now again, I can multiply these because I have a power raised to another exponent. So moving up here, we have 3 to the 6x equals 3 to the negative 2x plus 2. And now that we have the same bases, we can essentially just set the exponents equal to each other. So we have 6x equals negative 2x plus 2, and then we can solve that. So add 2x, we get 8x equals 2, divide by 8, 2 8s can be reduced to 1/4. Okay, last problem. This is a different type of problem because we're asked to rewrite it into let's do this color, y equals a number times a single number to the x. And right now we don't have that because we have it raised to the 2x minus 1 power. So we're going to just break it down again, kind of working backwards with the exponent properties to rewrite. So we're going to keep 4. We're still going to have 3 as our base, but we're going to write 3 to the 2x times 3 to the negative 1. Because even though this is subtraction here, it's really adding a negative 1. And so if we had this and we worked to put them together, we'd have 2x here minus 1, which would give us the top part. Okay, so we've rewritten it this way. Let's keep going. 3 to the negative 1. That's a third. 4 is going to stay there. Now we have 3 squared, and if we're multiplying 2 times x, we know 3 squared raised to a power of x is the same thing. And so if I keep simplifying this, actually I'm going to keep simplifying it up here. We have 4 times 3 squared, which is 9, raised to the x power times 1/3. We can multiply 1/3 times 4. When we do that, we get 4/3, and then times 9 to the x, which was the form we wanted. A single number times a single number to the x.